Good evening, students. How are you? This is Ankit Joshi. I welcome you all on India's largest e-learning platform, BYJU'S Exam Preps. This is our YouTube channel, students, and we are into the Signals and System MSQ series. So, master MSQ with me in Signals and System. So, students, I just request all of you to stay tuned, share the link in all your contacts, and please hit the like button. Students, Raghuram, I'm extremely fine, beta. What about you? Good evening, Raghuram, Shubhankar. I can see few students online as of now. I request all of you to share the link in your groups so that maximum number of students should get the advantage of this session. Hello students. So signals and system. So students, once again welcome to BYJU'S Exam Preps YouTube channel. So students, this is the channel for EC electrical instrumentation, and here we are doing MSQs on signals and system. This is Ankit Joshi. I welcome you all on this channel. So let's proceed. Students, this is the brief introduction about me. I have been teaching in this domain since many years, and my subjects of interest are engineering maths, signals and system, and analog circuits. So students, today we will be doing signals and systems MSQs. Yes, we will start the session now. Student, before me starting this session, I just request all of you to have a look over this. You can see Rakesh sir in the background image. So Rakesh sir will be taking a mega workshop for GATE 2024. Just book your calendar for 29th of Jan 12:30 afternoon. So Rakesh sir, your favorite Rakesh sir will be there for this session. No, Vittal Prasad, discrete time Fourier series and discrete Fourier series. Yes, discrete. Yeah. You can say same. DTFS and DFS are same. Correct. So, students, on your screen now you can see the announcement for All India Open Mock Test for GATE 2023. So this one is relevant for you. Okay. So dates are from 24th Jan to 30th Jan. You can take this test on any of the convenient dates. Student, here comes our first question. We are having a continuous time signal 6 sine 25 pi t plus cos 60 pi t. 6 sine 25 pi t plus cos 60 pi t. Now signal g of t. This signal g of t is passed through this system. What kind of system it is? Just a moment. Okay. All fine. So student, let's solve this question. There is a signal g of t. In this signal g of t, there are two frequency components. This signal g of t is passed through this system. This system is a sampler. So you need to tell us what is the fundamental frequency of this output signal, that is the sampled signal, and what are the fundamental frequencies of this unsampled, that is the continuous time signal. Okay, so for doing this I will just note down this question on the next frame. So I just need the frequencies. So student, signal g of t has got two frequencies, 25 pi and 60 pi. So signal g of t has two frequencies, 25 pi radians per second and omega 2 is 60 pi radians per second. Okay students, we have got these two frequencies. Now first of all we will work out the fundamental frequency. So students, what you need to do, there are multiple ways to do this. I'm just finding out, I'm just writing it as 2 pi f1. So 2 pi f1 is 25 pi and 2 pi f2 is 60 pi. Yeah, traditional method. So f1, pi and pi gets cancelled and you will get 25 by 2 hertz. What about f2? Pi cancelled, 2 is also cancelled, so f2 will be 30 hertz. So t1 will be reciprocal of this, that is 2 by 25 seconds. t2 will be 1 by 30 seconds. So students, once you take the LCM of numerators and HCF of denominators, so LCM of numerators is 2, HCF of denominators will be 5. So 2 by 5, that is 0.4 seconds. 0.4 seconds is the time period for g of t. What about fundamental frequency? Fundamental frequency will be reciprocal of this, that is 5 by 2, that is 2.5 hertz. So for the signal g of t, fundamental period is 0.4 seconds and fundamental frequency is 2.5 hertz. Let us check which options are correct. See, for signal g of t, fundamental period is 0.4 seconds. So this one is the correct one. Ye correct ho gaya? Yes. Then fundamental frequency of g of t is 2.5 hertz. This is also correct one. Now, what to do? This signal g of t is sampled. So what happens if you do the sampling? Just you need to replace t by nts. T will be replaced by nts. So what is the sampling frequency? 5 hertz. So t will be replaced by n upon fs. T will be replaced by n by 5. So wherever you have t, that t will be replaced by n by 5. So after sampling you will get g of n, which is 6 sine. Anji, please concentrate. 25 pi. T is replaced by n by 5. Okay, 5 cancelled. Then cos 60 pi. T is replaced by n by 5. So students, from here, what is the coefficient of n? This is omega 1. So omega 1 will be, kitna hai? Omega 1 will be what? 5 pi. And omega 2. This is the notation for frequency in discrete domain. Omega 2 will be what? 12 pi. So students, what you need to do? You need to first find out n1 and n2. What is omega 1? Omega 1 is 5 pi. Omega 2 is 12 pi. Correct? Now we will be first find out n1. n1 is 2 pi by omega 1 into k. And n2 will be 2 pi upon omega 2 into k. So n1, 2 pi by 5 pi. So 2 by 5 k. n2 will be 2 pi by 12 pi. So 1 by 6 k. So students, you need to just work on the minimum possible integer value of k, so that this n1 will be an integer. So I am selecting k equal to 5. So n1 will be 2. Here I am selecting k equal to 6. So n2 will be 1. Now what is the LCM of n1 and n2? LCM of n1 and n2. LCM of n1 and n2. That will be n. So LCM of 2, 1, that will be 2. So fundamental period will be 2 and fundamental frequency of this discrete time signal will be 1 by 2, that is 0.5 hertz. So students, for the discrete time signal, fundamental period is 2 and fundamental frequency is 0.5 hertz. Fundamental frequency is given as 5 hertz, so that will be wrong in the options. Okay, in option A, 5 hertz frequency for g of n, this is wrong. And fundamental period of g of n is 2. Yes, yes sir, it is. Fundamental period is 2. Correct. So option C is the correct one. So can we say that in this MSQ question, B, C and D are the correct answers? Okay. So this question involves simple concepts, but lot many calculations needs to be done. Okay. Yes. So I need responses from everyone. Moreover, I request all of you to hit the like button if you have not done so. And I request all of you to share the link in all your contacts. If you have not yet joined my Telegram group, it's a request to all of you, join my Telegram group. Why? Because you will get updates regarding my future classes and you can get the PDF of the sessions, classroom PDFs. Hello Shri Harsha, how are you? Now, this beautiful question now, again coming from the basics only, consider a signal y of t as given below. So we need to, okay, this is the signal. Manasvi Agarwal, is their playlist for EC syllabus complete? You can find sessions here and there, but definitely all topics are covered. Many topics are covered in YouTube. Okay, yeah. So all the demanding topics will be there, required topics. So students, this is the signal. Okay, we want to calculate the energy of the signal. Understood? Now I can give you a concept first before explaining that. If you are having a rectangular signal whose width is t and amplitude is a, so energy of this signal will be a squared t. If you are having a symmetrical triangle of width t and amplitude a, then energy in this signal is a squared t by 3. Now if you are having only a right triangle, either right side or left side, what is the width? Width is half to this, so energy here will be a squared t by 6. Understood? So students, just try to follow these concepts. These are very important concepts. This will be helping you in all other calculations also. Comfortable? Yes sir. Yes Raghu, very nice beta. I request all of you to stay tuned, don't go away. Yeah, see here. I need the energy of this trapezium. So students, if you closely observe figure 1 plus figure 3, figure 1 plus figure 3 will be giving us a symmetrical triangle. If I add these two, if I add figure 1 and figure 3, I will be getting a symmetrical triangle. Okay, so energy present in figure 1 and figure 3 this will be a squared t by 3. A squared t by 3. Okay, can I write this way? A is 5, so 5 square. What is the value of t? T will be this 2 and this 2. So 2 plus 2, t will be 4 upon 3. So 25 into 4, 100 by 3 joules is the energy present in figure 1 and figure 3. What about the energy present in figure number 2? Figure number 2 is a perfect rectangle. So its energy will be a square t. So a square t. Amplitude is 5. And what is the width? The width is 6. Width is 6. So 25 into 6 is 150. So all my dear students, the net energy of this signal is addition of all this. 100 by 3 plus 150. So 100 by 3 means 33.33. 33.33 plus 150 will be 183.33 joules. So energy in this signal y of t is 183.33 joules. Comfortable with this? It means option B is automatically going wrong. If option A is correct, then by default option B is wrong. What about option C? I will hide myself for few moments. Now please concentrate, all my dear students. See how to generate this signal present in option C. 2y of t by 3. See, starting from y of t, if you do time scaling by factor of 1 by 3, if you do time scaling by factor of 1 by 3, this will become y of t by 3. And at last, we are doing one more calculation. What? We are doing amplitude scaling by factor of 2. So we will get 2 times y of t by 3. Okay. Now please concentrate. If we say energy of y of t is E, then when you time scale a signal by some constant, that energy will be divided by that factor. So E will be divided by 1 by 3. Correct? Yes. And when this signal is going through amplitude scaling by factor of 2, the previous energy will get multiplied by 2 square. So the final answer for option C will be yes, 3 into 4, 12 times E. 12 times E, and 12 times E means 12 times this, 12 times 100 by 3 plus 150. Correct? So students, 100 by, okay, 12 by 3 is 4, 100 into 4 is 400, and 12 into 150 kitna hoga? 1800. So this will be 2200 joules. Option C is perfectly correct. 2200 joules for option C. For option C. What about for option D? For option D, students, please concentrate. Please concentrate. Please concentrate. Please concentrate. See, in option C, we want this signal. हमें ये signal चाहिए. So what you need to do to perform this signal? क्या करना होगा? See here. We start with y of t. Then what? then we will be doing time scaling. What if you just do one thing? This is 3 times y of t plus 6 by 2, correct? This signal can be written as 3 times y of t plus 6 by 2. क्या हम ऐसा लिख सकते हैं? Can we write this way? Yes. So now what I am doing? I am doing time scaling by factor of 1 by 2. So I will get y of 1 by 2. Then I will be doing time advancing by factor of 6. So t will become t plus 6 upon 2. Correct? At last I am doing amplitude scaling by factor of 2, so that I will get 2 times y of t plus 6 by 2, which is actually your requirement, y of t by 2 plus 6. Correct? Not plus 6. 6 by 2 will be 3. Comfortable? So y of t by 2 plus 3. Now I am just writing their energies here. Energy of y is E. Energy of y of t by 2. When you time scale by factor of 1 by 2, the original energy will get divided by this factor. So E upon 1 by 2 will be T. When you advance by 6, energy does not change by time shifting operation. So energy for this signal will be 2E only. And when you amplitude scale, energy will be multiplied by square of the scaling factor. Square of the scaling factor, square of 2 multiplied by previous result. So ultimately it is 4 to the 8. 8E is our answer. Correct? 4 to the 8, 8 to the 4 to the 8. 8 is our answer. 8 is our answer. Correct? Am I correct? Have I done everything correct? Yes. Okay, amplitude scaling factor is not 2, it is 3 here. Sorry, it is 3 here. It is 3 here. So I need factor 3 here. 3. So 3 is here. It means here you need to multiply it by 3 square. So 9 2s are 18. 18e. 18e. Yes, Naveen, I corrected beta. 18e. So this is e. 18 multiplied by this. So 3. Okay, 6 into 100 will be 600. Please calculate. 18 by 18 by 3 6, so this will be 600. 18 into 150 will be 2700. So 2700 plus 600, come on yaar, fast बताइए कितना आंसर है? 3300 joules. मनस्वी, why 3? Because we require this one. ये देखो, come on, comfortable everyone? So option D is also the correct one. So we can say that options A, C and D are the correct ones. What happened, Yashwant? Next. Now see this. Delta T is a unit impulse signal. Okay, take the first one. 0 to 15 x of t delta t plus 5 dt. Now you tell me what is the position of this impulse? This impulse is present at t equal to minus 5, which is outside this range of integration. Range of integration se bahar hai. So if this impulse is outside this range of integration, then this integration will be 0. It means the value of a is 0. The value of a is 0. The value of a is 0. Okay, are you following? Option A is wrong. Okay, comfortable? Now we want value of B. Acha ji, I'll just hide myself. Need your help. Second part. Take you y of 2t plus 4. Before that, delta 2t plus 6. Delta 2t plus 6. So if you take 2 common, it will come out like this, and this will become t plus 6 by 2, that is 3. So this is the resolution for delta 2t plus 6. Now y of 2t plus 4 is multiplied by 1 by 2 delta t plus 3. So answer will be this adjacent signal will be evaluated at the position of the impulse, further multiplied by the same impulse. Don't forget to multiply it again. Okay, in convol A is wrong. Yes, A is wrong. Correct. Now this, just calculate this at the position of the impulse. So t equal to minus 3. So minus 6 plus 4 is minus 2. So y of minus 2 by 2 and delta t plus 3. This is our answer. Option B is the correct one. Option B is the correct one. See, now see this third one. Third one involves convolution operation. तीसरे में convolution involved है. So x of t plus 2 convolved with delta 2t plus 6. X of t plus 2 convolved with delta 2t plus 6. Okay, so students, x of t plus 2 is convolved with 1 by 2 delta t plus 3. Now remember, whenever a signal is convolved with an impulse, the answer is adjacent signal at the position of the impulse. Answer is adjacent signal at the position of the impulse. So impulse is located at minus 3. So here you need to put minus 3 plus 2 upon 2. So all my dear students, in convolution operation, we do not write delta t plus 3 along with the final answer. Okay, but if this would be multiplication, in that case we would have written the same impulse along with the answer. Okay, so currently my answer is x of minus 1 by 2. x of minus 1 by 2 correct है क्या? x of minus 1 by 2, no. So we can say that option C is wrong. Option C is wrong. Option D is also wrong. Comfortable? What is our C? Our C is x of t plus 2. Na? X of t plus 2 convolution with delta 2t plus 6. Correct. Correct. Yeah, this is option C evaluation, Raghuram. All of you stay tuned, hit the like button if you have not done so. Join my Telegram group if you have not yet joined, because you can download the PDF. You can download the PDF. You can download the PDF from my Telegram group. All of you can download the PDF immediately after the session from my Telegram group. I just shared you the Telegram group link. Comfortable, everyone? Can we say that this question has got only one correct answer? Option B. Yes. So moving to the next question. See here. This question is based on the basics of the signals. So it involves systems. So students, y of t is 5 times d square by dt square xt. Okay. Now students, just see the options. Here we have to test linearity. Okay. Here we have to test time invariance. And yes, both linearity and time invariance. So if you just observe the first system, y of t क्या है? Y of t is 5 times d square by dt square x of t. So students, even if you differentiate, it is a linear operation. Okay, so this y of t is having constant coefficient, this double derivative is having constant coefficient. So constant coefficient means amplitude scaling, it is linear. Double derivative, again it is linear. So both of the terms are linear, no non-linear terms are involved. So this is a linear system. Okay, what about time invariance? Students, phi of t is having constant coefficient. Whenever there is constant coefficient, that is time invariant. Double derivative is again a time invariant, and its constant coefficient is also time invariant. So this is linear plus time invariant. Okay, so system P, okay, P is linear and time invariant. Very nice. Coming on to the option Q. Coming on to option Q. Y of t is e to the power 2xt. Now it is quite obvious that e to the power a plus b is not equal to e raised to a plus e raised to b. That's why this system is not linear. because it is not obeying additivity. Okay, at the same time it does not involve any of the time coefficients, any of the argument scaling, so this is time invariant. So linear and time invariant, this is linear and time invariant. Understood? This is purely scaling. Amplitude, this is constant coefficient, purely scaling. So this is linear as well as time invariant. Just this is option Q is non-linear. Huh? Extremely sorry. Option Q is non-linear. Extremely sorry. Option Q is non-linear because exponential is a non-linear operator. E raised to a plus b is not obeying additivity, as I already said. This is non-linear. This is non-linear. This is non-linear. This is non-linear. Option Q is non-linear. Option R is linear. Now see here. In y of t equal to 2x of t plus 3, this 3 is not allowing the system to be linear. So this 3 is the obstacle. So currently this is non-linear, but this is time invariant. Now read the options one by one. एक एक option का इलाज करते हैं. P and R are linear systems. P is linear, R is linear. Option A is the correct one. Okay, system S is linear. We will just see option B little bit later. System Q is time variant. System Q is time invariant. This is wrong. System P and R are LTI systems. System P and R are LTI system. System P and R, just a moment, Vishal, but I just get back to that question. System P and R are LTI. P is LTI, correct. R is LTI, that is also correct. Yes, this is correct. What about option B? System S is linear for suitable clamping, correct. So this is system S. If you just remove this DC level, this will become linear. Are you following my point? Removing or adding DC level is called as clamping. If you do a clamping, negative clamping by factor of 3, this 3 will be suppressed. This 3 can be suppressed by clamping operation. Yes. If you suppress this 3, then this system will become linear. So option B is also correct one. Okay. Now let's see what is the mistake in the previous question. Yes, Vishal, I'll see that. I have done a mistake. I accept my mistake here. I accept my mistake. Okay. Option C. Someone has really asked me to check option C earlier also. I just missed that. Extremely sorry for that. Students, delta 2t plus 6. Delta 2t plus 6 can be written as 1 by 2 delta t plus 3. Correct. So when you, so this is the convolution operation, na? So when you convolve x of t plus 2 with delta t plus 3, so this 1 by 2 as it is, but this adjacent function will be coming, but argument will be changed. So net shifting will be there. So 2 plus 3, 5 will be there. Bacha lo, 5 will be there. 5 will be there. 1 by 2 x of t plus 5. 1 by 2 x of t plus 5. 1 by 2 means 0.5. Option D is the correct one, and this one is wrong. All right. Yes. So now it is absolutely correct. So very nice. All right. So this is the time shifting property of convolution, that whenever a signal is convolved with impulse, the same signal repeats but with the net shifting. So what is the net shifting? 2 and 3. This will be 5. Okay, sir. Suppose if you are convolving x of t minus 3 with delta function t plus 7, then what will be the answer? Answer will be this signal x of t. Don't close the bracket, just do the net shifting. Minus 3 plus 7, it will be 4. So this is how we This is how it works. Okay, can I proceed? Yes, Vishal, thanks for reminding me. This one is again a beautiful question ahead of you. Let's see. Video stuck? No. Let's refresh. Now please concentrate. See the poles of this system. Okay, we'll discuss it. See what is this y of t? This is y of t, no? This is y of t. This is y of t. If this is y of t, then before integration it should be y dash t, and before this integration it should be y double dash t. Now see, y double dash t, these are the signs that should be given with the question. Y double dash t, when integrated, it will give you y dash t. Y dash t on integration will give you y of t. Comfortable? Yes, sir. So students, if you see here, this is x of t and this is your y of t. This one is y of t. So the input output relation will look like Anji, x of t minus y of t equal to double derivative of t. At this adder, I am applying the node. So x of t minus y of t will be y double dash t. So students, y double dash t plus y of t will be x of t. Okay, sir. So if you just write this in d form, so d square plus 1 y of t common equal to x of t. Can we write this way? So when you write the auxiliary equation to solve a differential equation, the poles are 0 plus minus j. Comfortable? So poles are plus j and minus j. Poles are plus j and minus j. Yes, sir. Now see this equation. See this equation. This is d2y by dt square plus y of t equal to x of t. So this is the input-output relationship. This is the input-output relationship. Yes, Satvika, Krishnaveni, Raghuram, Raghu, Payash, Vishal, everyone. Double derivative with constant coefficient, y of t with constant coefficient, x of t with constant coefficient. So this is linear as well as time invariant. Linear as well as time invariant. Option D is correct one. So option A and D are the correct ones. B and C are wrong options. Nice question it is. Are you enjoying? कमेंट बॉक्स में आग दिखना चाहिए, आग. Next, all of you see this question. See, h of t is e to the power minus 60. E to the power minus 6 mod of t. This is a टेंट सिग्नल. ये है टेंट सिग्नल. हाँ जी रोहित भाई, टेंट सिग्नल जानते हैं? डू यू नो टेंट सिग्नल? e raised to minus t when t is greater than equal to 0 and e raised to plus t when t is less than 0. it means it should be exponential rise for negative values of t and exponential decrease for positive values of t. This kind of signal will be obtained. So students, it is quite obvious that this system, this h of t will be giving you a finite area, correct? If this is giving you finite area, it means integration from minus infinity to infinity, h of tau modulus d tau. When you integrate this will be a finite value. Arey bhaiya, this graph is bounded, so this integration will be finite. Therefore, we can say that h of t is absolutely integrable. This is absolutely integrable. So h of t is absolutely integrable. Therefore, h of t represents a stable system. H of t is absolutely integrable. Therefore, h of t represents a stable system. Moreover, h of t is both sided na. On time axis, h of t is both sided. So system is non-causal, both sided non-causal. So anti-causal is wrong and not absolutely integrable is also wrong. So options B and C. This is an MSQ. This is an MSQ session. So in an MSQ question, more than one correct answers are there generally. Come on, hit the like button. Stay tuned for the best of the concepts. Let's proceed for the next. See here. Now this is a signal. X of t is given. It has got one cosine component, one sine component, and a DC component. So signal x of t is passed through a low pass filter with cutoff frequency pi radians per second. Okay, G. So what we can do here, omega 1 is 3 pi by 2 here, and omega 2 is 5 pi by 3. Now we can just find out f1 and f2. f1 is divide 3 pi by 2 pi. So 3 by 4. 5 pi by 2 pi. 5 by 6. So t1 will be 4 by 3 seconds. t2 will be 6 by 5. So what if you take the LCM of numerators? LCM of 4 and 6. LCM of 4 and 6 कितना होगा? 12. And HCF of 3 and 5 is 1. So t will be 12 seconds. So fundamental frequency will be 1 by 12 seconds. 1 by 12 hertz. So students, x of t is a periodic signal. Yes, it is periodic signal with fundamental frequency 1 by 12 hertz. That is perfect. Now we have to do a bit of harmonic analysis to know which all components are present in x of t. Okay, so it is quite obvious that x of t is having one DC component. So DC component, I am okay with this, but let us work on this harmonics. Friends, just remember 2 pi n f naught. Compare your omega 1 with this. Once again, 2 pi n f naught. Compare your omega 2 with this. What is omega 1? Omega 1 is 3 pi by 2. 3 pi by 2. What is omega 2? Omega 2 कितना है? 5 pi by 3. Now, students, see here, pi cancel. 4 n f naught equal to 3. What is f naught? Sir, f naught is 1 by 12. 1 by 12. 1 by 12. Anji. So n will be Anji. 4 cancel 3 times. 3 3s are 9. So this frequency is the 9th harmonic. Now 2 pi n. What is f naught? What is f? Okay, make it okay. Pi cancelled. 3 is brought to the left hand side. 6 pi. अरे pi cancel हो गया भाई. and f naught is 1 by 12 equal to 5. So it is cancelled 2 times and will be 10. So we have 9th harmonic and the 10th harmonic, correct? So our signal has got our signal has got our signal has got DC component, 9th harmonic and the 10th harmonic. It means 3rd and 5th harmonic. This is wrong. Option B is wrong. Option A correct hai. Option B is wrong. Now they are asking for average power of the signal at the output. Now what is the output? Hey bhaiya, this signal X of t is passed through a low pass filter whose cutoff frequency is pi radians per second. So I am drawing a low pass filter, low pass filter, low pass filter, low pass filter. X of t is the input. Let us say y of t is the output. Cutoff frequency is pi radians per second. So I am going to draw h of omega, and the cutoff frequency is pi radians per second. Pi radians per second. The amplitude should be 1 and this is minus pi to plus pi. This unit will be radian per second. Now all my dear students, what is omega 1 and omega 2? Omega 1 is 3 pi by 2, means 1.5 pi. 1.5 pi will be outside this. What is omega 2? What is omega 2? Omega 2 is 5 pi by 3. 5 pi by 3. 5 pi by 3 का मतलब होता है 1.66. So this is also outside this interval. Enter n. Omega 1 and omega 2 both are outside this filter. So it will pass only the DC component. So output y of t will be simply 1 by 2. Yes sir. So energy nahi, power. So power, average power in the output. Average power in the output will be square of the DC component. So 1 by 4. 1 by 4 means 0.25. Watt लगा दो इसकी. 0.25 watts will be the answer. 0.25 watts. So average output, average power of the signal at the output is 0.25 watts. Option C is the correct one. 0.25 watts. So by default option D goes wrong. We can say A and C are the correct options. A and C, A and C, A and C are the correct options. How many of you agree with me? फटाफट respond कीजिए. There are 30 plus students. I am not even getting more than 5 responses. तो जिंदा होगा वही तो आवाज करेगा. कभी दिए के आगे पल दो पल बर्बाद कर लेना. दिए के आगे पल दो पल बर्बाद कर लेना. दिए के आगे पल दो पल बर्बाद कर लेना और पतंगा जब जले कोई याद कर ले. Next, A and C are the A and C are the A and C are the correct options. So I have got few more responses, but still many more can come. Many more can come. See here, next question. For which of the following signals Fourier transform can be obtained from Laplace transform? So students, just keep in your mind, you can obtain Fourier transform from Laplace transform. You can obtain Fourier transform from Laplace transform, but for only those signals, which are absolutely integrable. हर वो सिग्नल जो absolutely integrable है, ये Laplace transform से Fourier transform derive किया जा सकता है. We can derive the Fourier transform signal from its Laplace transform only if that signal is absolutely integrable. If a signal is absolutely integrable, then only its Fourier transform can be obtained from Laplace transform. How? By putting s equal to j omega. हर वो सिग्नल absolutely integrable है. ये लाप्लास ट्रांसफॉर्म के रिजल्ट में s की जगह पर j ओमेगा सब्स्टिट्यूट कीजिए, you will get the Fourier transform. Okay, so this is the logic. So let us check. Just you need to find out which of the signals are absolutely integrable. You need to just find out which of the signals are absolutely integrable. So option A, 5 times delta t minus 3, x1t, x1t. This is my x1t. This is my x1t. This is my x1t. So I am getting an impulse whose strength is 5, and this impulse is obtained at 3. So students, this signal, this is the signal, yeah, this is the signal, ये है वो signal. Okay, so this is the signal. This signal is absolutely integrable. This signal is absolutely integrable. You know this? Yes, sir. So this is our correct answer. Option B. ऑप्शन बी कैसा है बच्चों? ऑप्शन बी का बनाता हूं मैं, x2t बनाता हूं आपके सामने. देखिए, this is t and this is x2t. Now this is 2 times e raised to at u of t. Okay, so this is an exponential rise. अरे भाई, ये तो absolutely summable, absolutely integrable नहीं हो सकता. This cannot be absolutely integrable. So this is the wrong one. Third one, x3t. x3t देखिए, x3t is a tent signal. x3t is a tent signal. Okay, this is also absolutely integrable. This is also correct one. 2u of t minus 1. 2u of t minus 1 जानते हैं क्या है? 2u of t minus 1. It is signal, right? This is also not absolutely integrable. So students, ultimately only option A and C, that is signal x1 and x3 and x3 are absolutely integrable. Hence their Fourier transforms can be obtained from the result of Laplace transform. Very logical question, very conceptual question. Moving to the next. Come on, आग लगा दो, आग लगा दो, आग लगा दो. चलिए, see this. Now see it. Average DC value of the signal. First of all, we need to work out the average DC component. So average DC component is say A naught, which is area under x of t in one period divided by duration of one period. It means just you need to calculate this area. Okay. The upper area will come positive and lower area will come negative. Okay, sir, we do it. What is the period? Period is 10 units. So area of this first rectangle and area of this second rectangle. Okay. So height is 8, width is 5. 8 into 5, 10, 10, and then here width is 5, height is minus 2. 40 minus 30, 40 minus 10 है भाई, upon 10. This will be 3. This will be 3. So 40 is also wrong, 30 is also wrong. Okay, 40 and 30 both are wrong. Comfortable? Now just we need to go for the symmetry of this. See, since this amplitude is not equally distributed above and below t-axis, therefore we need to draw a dummy t-axis passing through the center of the signal. Since the amplitude of the signal is not equally distributed above t-axis and below t-axis, so we have to draw a dummy t-axis, a new t-axis passing through the center of the signal, and this process is called as hidden symmetry. We are applying hidden symmetry. Okay, so we are just drawing this dummy t axis passing through the heart of this signal. It means total height is from, so peak to peak amplitude is 10 units. So minus 2 plus 5, that will be 3, and 3 plus 5, that is 8. So this amplitude is 3. Understood? Yes, sir. Now, with the help of this new origin, ये नया जो origin है, this new origin, this is first quadrant and this is third quadrant. We can say that this signal is symmetrical with respect to new t axis. कोई response नहीं है. This signal is symmetrical about the origin, about this new origin. So we can say that odd symmetry is followed. Odd symmetry follow हो रही है. Odd symmetry is also obeyed. Now, if you shift this signal half period right side, if you shift this signal half period right side and amplitude fold, both the signals are same. If you shift this signal half period right side and amplitude fold, are you getting the same signal? Yes. It means half wave symmetry is also obeyed. Half wave symmetry is also obeyed. So students, odd symmetry is there, odd symmetry is there, odd symmetry is there with respect to hidden symmetry, odd symmetry is there. So cosine terms are absent, only sine terms will be there. Sine terms will be there. Half wave symmetry means odd harmonics will be there. Odd harmonics will be there. Okay, what about the DC component? DC component is there because we have already calculated non-zero DC component. So the Fourier series has DC component plus odd harmonic sine terms. DC component will be there because this wave is not having symmetric. This wave is not having symmetrical amplitude with respect to given t axis. Okay, therefore DC component will also be there, and we have already calculated this DC component. DC component is non-zero. Then we applied this dummy t axis. This dummy t axis application means hidden symmetry. After hidden symmetry, we got odd symmetry and followed by half wave symmetry. Odd symmetry means sine terms will be there. Half wave symmetry means odd harmonics will be there. So DC component and odd harmonic sine terms will be there. Odd harmonic cosine terms, this is wrong. X of t has odd harmonic sine terms and DC component. Option D is the only one. Option D is the only correct answer. Again, a beautiful question from Fourier series symmetry analysis. Will I get your response? क्वेश्चन में मजा आया क्या? Next. Satvika. Gates super 11 top 11 questions from every subject. Students, beautiful series, a very important series for you is going to start from 27th of Jan. 27th of Jan. See here. See, super 11, top 11 questions from all the subjects. Every day, one subject. Yes. So, students, just have a screenshot of this. Book your calendar for 27th of Jan. Okay? Yes, sir. So, super 11, we will just work out, we'll just sort out the best 11 questions from the subject, and one day each subject, 11 questions. I don't think not, it will be around say only 40-45 minute session, but this very, very helpful for your preparation upcoming GATE exam. Students, don't forget to join the live analysis on 4th and 5th Feb. Timing is 1 p.m. and 6 p.m. If you have not yet subscribed, subscribe this channel if you have not yet subscribed. Now the next question. KK, Fourier transform is that chapter that you should not skip. If x of t is given as like this, and x of t is having Fourier transform x of omega, okay sir, then 0 to infinity x of omega d omega is 1. Okay, we'll let you know. We'll let you know everything. See. By inverse Fourier transform definition, 1 by 2 pi minus infinity to infinity x of omega e raised to j omega t dt. Yes, Satvika, correct. किडनी की जरूरत ज्यादा उन लोगों को होती है, अरे जाने दो, लिवर और किडनी किसका सुरक्षित होना बहुत जरूरी है. So students, when we put t equal to 0, you will get x of 0. You can just cross multiply this 2 pi. You are getting minus infinity to infinity x of omega e raised to 0 is 1 dt. Okay. Now this signal this spectrum x of omega is symmetric, sinc function. So 2 pi x of 0 is 1, so this is 2 pi. But if I write the limits of integration as 0 to infinity, then this can be multiplied by 2. So the value of this integration should be pi. So 0 to infinity x of omega d omega is wrong. If I just put the limit minus infinity to infinity x of omega d omega, then this should be 2 pi. This we already proved. Minus infinity to infinity, yes, this is 2 pi x of 0 is 1, so this should be 2 pi. X of 0 is 1, so 2 pi is the correct answer. Okay, what about capital X of 0? See, capital X of 0 is area under the signal. That is area of this rectangle. Area of this rectangle will be 2 into 1, that is 2. This should be wrong. So students, we really appreciate those students who are giving the correct answers. So Fourier transform is an easy topic, but this is the heart of the entire subject. You should not skip this. So student, the answer for this is 2. Comfortable? So we can say that options C and D are the correct ones. Moving to the next. See this one. x of t is 5 sine 100t upon pi t. and x of omega is the Fourier transform. So students, let us find out x of omega. Let me give you one formula. See, if you are having a signal sin AT upon pi t, sin AT upon pi t, then its Fourier transform will be rect omega by twice a. If you wish to draw the graph, this will be from minus a to plus a, and this height will be 1. Okay, this is the spectrum, rect omega by twice a. Comfortable? Comfortable, students? Now see here. What is x of omega? X of omega will be five is also there now, so 5 will be copied as it is, and then we have rect of omega upon 2a. Here a is 100. Okay, so this should be from minus 100 to 100, amplitude 5. Minus 100 to 100, amplitude 5. Option C is the correct one, and that's why option B is wrong. Now, let us work on the energy of the signal x of t. Energy of the signal x of t. So student, if you wish to calculate the energy of signal x of t, it is 1 by 2 pi energy of the entire spectrum. Area under the spectrum. Area under this spectrum will be 5 into 200. So this is 1000 by 2, 500 by pi. Something wrong? Okay. $500 by pi. This is the energy for signal x of t. Now we want the how can you calculate the energy? 5 square. Oh, missed out. So energy 5 square will be there. Correct. You are absolutely correct. So 2500, 2500, 25. Okay. 5005 हो जाएगा ना. 5000 by 5000 by 2, 2500 by pi joules. So this is the energy for this signal. So this should be wrong. What about time delay? Whenever you do a time shifting, energy will not change. Energy will not change. So the same energy will be applicable to this signal also. With time shifting operation, energy will not change. Okay. 1 upon 2 pi minus infinity to infinity x of omega magnitudes square. That was the logic. So 1 by 2 pi, 5 square came out, and the area of the rectangle. So width is from, width kitna tha? Width kitna tha? Width is 200. This is the answer. Of course, Raghuram, you will get this PDF file. So options C and D are the correct ones. Comfortable with this? One more question. Now coming on to the Hilbert transform. So students, when you take Hilbert transform of sin omega naught t, what is the answer? See, sin omega naught t, its Hilbert transform will be sin omega naught t minus pi by 2. If you take minus sign common, it is sin pi by 2 minus omega naught t. Use the complementary angle formula. It is minus cos omega naught t. Okay. Yes, sir. And when you take Hilbert transform of cos omega naught t, it is cos omega naught t minus pi by 2. Even if you take minus sign common, cos of minus theta is cos theta. So this will be simply sin omega naught t. So these are some important results. Moreover, no tuing session is started at 9 p.m. Moreover, whenever you take Hilbert transform 2 times, the original signal gets multiplied by minus sign. That's it. Now see, cos of omega naught t Hilbert transform will be sin omega naught t, and x2 t is, see, 2 times Hilbert transform taken, so it is minus cos omega naught t, and here x3t will be minus sin omega naught t. Now check with the answers. x1t is cos omega naught t. This is wrong. x2t is minus cos. x2t is minus cos. This is correct. x1t into x3t. x1t into x3t minus sin square omega naught t. This is also correct. And x1t into x2t into x3t, the product of all three, तीनों का product क्या होगा? Minus minus plus sin square into cos. This is wrong. Wrong है ना? Options B and C are the correct ones. Next. This is the evaluation process. What is Hilbert transformer? Hilbert transformer is a minus pi by 2 phase shifter circuit. Hilbert transformer is an all pass system. It provides a minus pi by 2 phase shift. For a distortionless transmission, amplitude response should be constant. Yes, Raghu. Amplitude response is constant with respect to frequency, and phase response is linear. So phase response is linear. Phase response must be linear. Amplitude response must be constant. Amplitude response is linear, then there is no, if amplitude response is linear, if amplitude response is constant, then there is no, this statement itself is complete blunder. See, for amplitude distortion, or amplitude distortion depends on amplitude distortion depends on amplitude response, and phase distortion depends on phase response. So options A and C are the correct ones. Next, Fourier transform. If x of t be a time domain signal having Fourier transform, so they have given you a time domain signal whose Fourier transform is x of omega. Fourier transform of this e raised to minus jt is correct, na? X of omega minus 1 will be here plus 1. So option A is the correct ones. This is a frequency shifting property. Yes. Magnitude spectrum of x of t and its time shifted version is same. When you do time shifting, magnitude spectrum will remain same. Yes, sir. Here, what is the frequency response? It is e raised to minus j omega 10 x of omega. So only the phase part will change, magnitude part will not change. So magnitude spectrum of both of these signal is same. Phase spectrum of x of t minus 2 changes. And what change is observed? A linear phase term minus 10 omega is added to the original phase. Phase spectrum of this contains a linear phase term. That is correct. Phase spectrum of these two signals are same. No, not at all. Options A, B, and comfortable. Have you all hit the like button? अभी तक लाइक बटन हिट नहीं किया है तो हिट कर देंगे. Next, see this. Let g of t is e raised to minus 8t u of t, and x of t is g of t convolution with g of t, and y of tau is ACF of g of t. अच्छा जी, very nice question. So g of t is given na, e raised to minus 8t u of t. Its Fourier transform is g of omega, which is 1 upon 8 plus j omega, correct? If you go for g of minus t, then it is e raised to 8t and u of minus t. Just replace t by minus t. Then in Fourier transform, omega will be replaced by minus omega. So this is the Fourier transform. Now what happens? There is a signal x of t, which is g of t convolution with g of t. Okay. So students, x of t is g of t convolution with g of t. So x of omega, that is the Fourier transform of this x of t, will be g of omega multiplied by g of omega. Wait Rupesh, wait, just go back. Multiplication of these two. So g of omega is multiplied by same function. It is 1 upon 8 plus j omega into 8 plus j omega. This is 8 plus j omega whole square. Okay. Now, if you take the inverse Fourier transform, then you will get x of t. So inverse Fourier transform of 1 upon 8 plus j omega whole square. This is t e raised to minus 80 u of t. Do you know this? Do you know this? X of t is t e raised to minus 80 u of t. Now what you want? You want value of x of t at t equal to 1 by 16. At t equal to 1 by 16. So t equal to 1 by 16. E to the power minus 8 by 16 will be minus 1 by 2, and u of 1 by 16 is 1. So this will be 1 upon 16 root e. 1 upon 16 root e. 1 upon 16 root e. Option A is the correct one. Behreen. Now, energy spectral density of g of t. Energy spectral density is g of omega whole square. But they are asking for frequency f of 0. See, energy spectral density of g of t is nothing but g of omega magnitude square. But we are requiring this at f equal to 0. Now what is g of omega magnitude square? This is g of omega square, right? ये हो गया बच्चों g of omega का square. So g of omega is this one. Its magnitude will be 1 upon under root 8 square plus omega square. So its square will not be having the square root. इसके square में square root नहीं होगा. So 1 upon 8 square plus omega square. We want at f equal to 0. F equal to 0 means omega equal to 0. So this will be 1 upon 8 square means 64. 1 by 64 should be my answer for this ESD. This is also correct one. And now we also want y of tau. What is this y of tau? Y of tau is autocorrelation function of g of t. autocorrelation function of e raised to 80 u of t. No, autocorrelation function of g of t. You know what is autocorrelation function? Y of tau is autocorrelation function of g of t. So this will be, so Fourier transform of this autocorrelation function will be, just a moment. So autocorrelation function of g of t will be g of tau convolved with g of minus tau. Chinmay Roy, I already written this, na? G of t, t e raised to minus 8t u of t. It's written here. Chinmay, देखो बेटा. Now, g of tau convolution with g of minus tau. When you take its Fourier transform, it is g of omega multiplied by g of minus omega. So ultimately it is say y of omega. So y of omega will be g of omega into g of minus omega, g of omega into g of minus omega, g of omega into g of minus omega. 1 upon 8 plus g omega, 1 upon 8 minus g omega. 1 upon 8 plus g omega. 1 upon 8 minus j omega. Comfortable? So students, it will be a square minus b square. Okay, sir. So if you take inverse Fourier transform, if you take inverse Fourier transform of y of omega, so it is 1 upon 16 Fourier inverse of 2a upon a square plus omega square, correct? So this will be e, okay, 1 by 16 is there, e raised to minus a mod of tau, and this is nothing but y of tau. Instead of t I am writing tau. Okay, sir. Now what we want? We want y of tau at tau equal to 0. So e raised to 0 is 1. 1 by 16 will be our answer. This is also correct, 1 by 16. The value of x of t at t equal to 1 by 16 is 1. Okay, this is wrong. So we can say that options A, B and C are the correct ones. Options A, B and C are the correct options. Is that clear? Next. See this. Two signals x1t and x2t are band limited to 2 kilohertz and 3 kilohertz. Shape of the spectrum is not known. We are just assuming something. 2 kilohertz and say this is 3 kilohertz. Okay. These are the two band limited signals. Nyquist rate of x1 to t. Okay. So students, when x1 is time scaled by factor of 2, its Fourier transform will be 1 by 2 x1 of omega by 2. Correct? Yes, sir. It means expansion is happening here. Expansion in frequency domain. Expansion in frequency domain means its maximum frequency will also get expanded. Maximum frequency will be doubled. So maximum frequency for x1t, maximum frequency for x1t is 2 kilohertz. So here it will be doubled and it will become 2 times 2 kilohertz. That is 4 kilohertz. And Nyquist rate Yes, to it. Nyquist rate will be 2 times F max. So this will be 8 kilohertz. Yes, my analysis is correct. So X1 2T is 2 kilohertz. This is wrong. Now X2T minus 3. X2T minus 3. What happens if you are time delaying a signal? Then that signal is just multiplied by complex exponential term, but the maximum frequency will not change. So F max will be same as that of X2. For X2 we have 3 kilohertz. So Nyquist rate will be 2 F max, that will be 6 kilohertz. So for X2 T minus 3, Nyquist rate is 6 kilohertz. Na? Nyquist rate is 6 kilohertz. This is wrong. Now X1T multiplied by X2T. When two signals are multiplied, their individual maximum frequencies are added together. So for option C, F max will be 2 plus 3, that is 5 kilohertz. So Nyquist rate will be double to this, that is 10 kilohertz. So this is correct. When two signals are multiplied together, their maximum frequencies are added together. So maximum frequency of X1 and X2 are added. 2 plus 3 will be 5 kilohertz. So Nyquist rate will be 2 F max, that is 10 kilohertz. When two signals are convolved together, maximum frequency will be minimum of the two. Put into one. F max will be minimum of F1 and F2. Minimum of F1 and F2. So minimum of F1 कितना है? 2,3. 2 kilohertz. So Nyquist rate will be 4 kilohertz. So for option D, 4 kilohertz is correct. C and D are the correct ones. C and D are the correct questions, correct ones. Now, student, ensure hitting the like button. Ensure hitting the like button. क्या आपने मेरा टेलीग्राम ग्रुप ज्वाइन किया है? Have you all joined the Telegram group? Have you all joined my Telegram group? I am going to share the PDF of this session on my Telegram group. If you are still not the part of my Telegram group, you will miss out the PDFs, you will miss out the updates of my next class. My next class, that is on, yes, next class on partial differential equation, tomorrow at 6 p.m. You know this? Partial differential equations, next class, 6 p.m. Do you know this? Consider a discrete time LTI system. Input is x of n, h of n is the impulse response, y of n is the output. H of n's z transform is h of z, okay, and h of z is already given, 6 times 5z minus 2, 6z square minus 5z plus 1. So students, Ashok, marathon class for analog electronics is already taken by legendary Sanjay Rathi sir, Faiz, just remind me on the group. I will provide the PDF. That I will do. Beta. That I will do. Just remind me after the class today. Okay. Chal. So in this particular question, h of z is given 6z square minus 5z plus 1. I am just equating the denominator to find out the poles. Okay. So students, so we can say that z minus, okay, z will be 2z common, so 3z minus 1 minus common 3z minus 1. So ultimately 2z minus 1 and 3z minus 1. So ultimately you have got two poles, z equal to 1 by 2 and z equal to 1 by 3. These are the two poles. Hai na? Now listen carefully, students. Listen carefully. See. This is real axis. Chinmay, we'll do it today, beta. We'll do it. Yes, yes. Maybe I forget due to some uh, urgency in other works, but definitely I will share it with you. Okay. Yes. So students, this is our real axis. This is the imaginary axis. This is the z plane. Now we have got two poles for the given h of z. Mod z equal to 1 by 3 and mod z equal to 1 by 2. Okay. Yes. So students, if you draw a circle of radius 1 by 3, if you see, this is a circle of radius 1 by 2, sorry, 1 by 3, and this is a circle of radius 1 by 2. 1 by 2 is greater than 1 by 3. Yes. So you have got three regions, regions R1, R2 and R3. So students, R1 is mod z less than 1 by 3. R2 is mod z lying between 1 by 2, 1 by 3 and 1 by 2. And R3 is mod z greater than 1 by 2. See, R1 is the region inside the innermost circle. R2 is the region between two concentric circles. And R3 is the region outside the outermost circle. Okay. Yes. Now see here. We will just discuss the nature also. When you are inside the region R1, जब आप region R1 में हैं, when you are inside the region R1, then it is anti-causal, system is anti-causal, and it is not including unit circle. When the ROC is not covering unit circle, अरे भैया, R1 doesn't cover unit circle, therefore it is unstable. So R1 represents anti-causal and unstable system. If your ROC is lying between 1 by 3 and 1 by 2, that is in this annular strip, annular ring, in that case, this is non-causal, both-sided. But still it does not include unit circle, so this is again unstable. When the ROC doesn't cover unit circle, it is an unstable system. It represents an unstable system. Mod z greater than 1 by 2. Mod z greater than 1 by 2 means outside this circle of outside the outermost circle. Outside the outermost circle means causal, and this outside the outermost circle will cover the unit circle, and that's why is. Now we will answer the various questions. Okay. H of n is stable and causal for mod z greater than 1 by 2. This is the correct one. H of n is stable and causal for mod z greater than 1 by 2. See here, mod z greater than 1 by 2, stable and causal. Then mod z lying between 1 by 3 and 1 by 2. System is not causal, system is non-causal, both sided non-causal. When mod z is less than 1 by 3, system is anti-causal. Yes, system is anti-causal. Mod z less than 1 by 3, system is anti-causal, system is anti-causal. Last one, mod z greater than 1 by 2, system is causal. Mod z greater than 1 by 2, system is causal. This is also correct. Yes, this is causal. Na? I think this option is wrongly written. It should be non-causal. If it is non-causal, then what should be the correct answer? Tell me. See, intentionally I am making this option D wrong. Manish Kumar, I got. Manish Kumar, I will definitely forward your concern. And actually, I am not aware of what is the process and what is the scholarship, what is the exact fees and all. But you just connect with me on my Telegram group, and I will just get to know the entire scenario and will let you know the exact situation. Okay? Yeah. Now see this question. Just go through this. See here. X of n is given. X of n is given as 6543. X of n is given as 654. See, on the corner you can see this 4. Na? This is called as modulo n shifting. Modulo n shifting. These operations we use in DFT. So this signal x of n is delayed by 2 units, but this is a circular shifting operation. Modulo n shifting or circular shifting, one and the same thing. It means the length of the signal will not change. So I will find out x of n minus 2. Before that, I will just find out x of n minus 1. So students, what you need to do? Just concentrate. 6 is moved to the next place, 5 is moved to the right side, 4 is moved to the right side, and 3 is coming to the first place. Okay, this will look like this: 3, then 6, 5, 4. If you do the similar operation once again, एक बार फिर से ऐसा करेंगे, then you will get x of n minus 2. So 3 is shifted to right, 6 is shifted to right, 5 is shifted to right, and 4 is coming in the first place. So 4, 3, 6, 5. So x of n minus 2 modulo 4 shifting is 4365. 4365. 4365. Option A is the correct one. Okay. Now I want x of n plus 1 4. It means I want modulo n shifting left side. So students, left side, left side, left side, left side, left side. Okay. So 5436. 5 is coming at first place, then 4, then 3, and then finally 6. So x of n plus 1, x of n plus 1 is 5, 3, 4, 6. This is wrong. D is wrong. Manish, if you can connect with me on my Telegram group, okay, I'll just connect you with the correct person. Okay, so students, now we are just checking the folding operation. Okay, now please concentrate. 4365 is the value of x of n. Four three six five. 4 3 6 5. 4 3 6 5. Okay, sir. Say this is 0 1 2 3. Since our signal is periodic, so same samples will be on the left side also. 4365. 4 3 6 and 5. 4365. Okay, now just give the negative numbers here. -1, -2, -3 and -4. Correct. So students, when you fold a signal, what happens? See, this is x of n. Okay, this is periodic, so this keeps on repeating. When you fold a signal, what happens? Zeroth sample will remain same. Sample at -1 will come at +1. So 5 will appear at +1. Sample at -2, that is 6, will appear at +2. And sample at -3 will appear at +3. See the sequence 4, 5, 6, 3, and this will go on continuously. 4, 5, 6, 3. This is x of -n. X of -n is 4, 5, 6, 3. Understood? 4, 5, 6, 3. So this is the logic of determining the folded signal in periodic samples. 4, 5, 6, 3. 4, 5, 6, 3. अरे भाई जीरो सैंपल इज 6 ना, मैंने क्या लिख दिया? एक्सट्रीमली सॉरी, 6543 था आज का सेशन, तो फायर है, ये मैंने मिस्टेक कर दिया, ये 6543 था, मैंने ये यहाँ से शुरू कर दिया क्या? चलिए कोई बात नहीं. So 6 will be my zero sample and 3, 4, 6, 3, 4, 5 should be the answer. Apply the same. अरे भैया सर फिर से करना पड़ेगा. I just wrongly written this x of n, that is the reason. गलती हो गया लिखने में. x of n plus 1 लिख लिया था by mistake. So x of n is 6543 ना. So this keeps on repetition. Now what happens? Whatever is there on the left will come to the right. Zeroth sample will remain as it is 6. Then sample at -1 is +3. It will come at +1. sample at -2 is 4. It is coming at +2, and sample at -3 is 5, which is appearing at +3. So 6 3 4 5, 6 3 4 5 beta, 6 3 4 5, 6 3 4 5. So A and C are the correct ones. A and C are the correct ones. A and C are the correct ones. Now see here. Thank you, Raghuram. What others think? Layer 2. See this question. The 4-point DFTs of x of n and y of n are given. Okay. G of n is circular convolution of x of n and y of n. Okay. G of n is circular convolution of we'll try, Raghuram. We'll definitely try to do that. You're asking about mathematics, I think. So G of n is circular convolution between x of n and y of n. Now, what about the DFT of G of n? DFT of G of n is G of k. Then if there is convolution in time domain, then in DFT domain there will be multiplication. X of k gets multiplied by y of k. Understood? Understood this one? So students, what you need to do, you need to multiply these samples. Okay, comfortable this with this? So 22 into 8 कर लेते हैं calculation. 22 into 8, this is 176. Now -4 plus j2 and -2 minus j2, multiply these second samples. -4 into -2 will be 8, j into j square is minus, and this minus plus 2 2s are 4. Now j2 into -2 is minus j4, minus minus plus j8, 12 minus j4, 12 plus j4. Now minus 6 into 0 is 0, and see this -4 minus j2 and 2 -4 minus j and -2 plus j2. What happens? Plus 8 minus plus minus, j square is -1, 2 to the -4 into j2 is 4, the rate j minus 8j, then plus j4. Correct? So this is real. So conjugation property is being obeyed. 12 minus j4. I got this one. I'll just repeat the calculation. What can be done? See here. We want g of 2 and g of 0. That's it. How to do that? Please concentrate. See. G of k, I have to use inverse DFT na, inverse DFT lena padega. Inverse DFT formula. X of n is 1 by capital N summation from k equal to 0 to n minus 1 x of k e to the power minus j 2 pi kn upon capital N. We are having 4-point DFT, so capital N is 4. And our signal is g of n, so we are writing g of n. K equal to 0 to 4 minus 1, that will be 3. X of k will be g of k, and e raised to j, capital N is 4, so 2 by 4, it is 2 in the denominator, so pi kn by 2. Pi nk by 2. Now what happens if you wish to calculate g of 0, then you have to put n equal to 0. So g of 0 will be 1 by 4 summation from k equal to 0 to 3 g of k. When you put n equal to 0, this term will vanish. So sum of all the samples of g of k divided by 4. Sum of all the samples of g of k divided by 4, and put n equal to 2. When you put n equal to 2, you will get g of 2. Small n equal to 2. So 1 by 4 summation k equal to 0 to 3 g of k. When you put n equal to 2, 2 gets cancelled, and you will get e raised to j pi raised to k. E raised to j pi is nothing but minus 1. So minus 1 raised to k will appear here. Okay. What happens? It's very simple. First of all, find out this. Add all samples of g of k divided by 4. Addition of all this. So what you will get? 176 plus 12 plus 12, 24 divided by 4. So 200 by 4 is 50. 50 is my answer. And so g of 0 is 50. So g of 0 is 200. That is wrong. Now g of 2. अब बारी आई g of 2 की. G of 2 कैसे होगा? In g of 2 we have this minus 1 raised to k. It means what? There will be alternate plus minus sign. So this is g of 0 will come as it is. Then g of 1, then plus g of 2, then minus g of 3, and so on, like this. So first one is plus, then minus, then plus, then minus. The students, 176, then minus 12, then plus 12. So ultimately 176 divided by 4. This is 176. Last one, no? 176 minus plus minus. 176 minus 24 divided by 4. Yes, I got it. 38 is my answer. Correct. 38 is our answer. G of 2 is 38. Option B and C are the correct ones. Option B and C are the correct ones. Comfortable? So I am going to give you one homework question. One homework question now. This is an homework question. Oh, we'll do it now. We'll do it. See here. You know this property, if x of n is real, then if its DFT is x of k, then x of k will be x of n minus k conjugate, and vice versa. X of k conjugate will be x of n minus k, like this. Okay? Yes, sir. So students, if you list this like this, so here they have said that it is 6-point DFT. So x of 0 will be x of 6 minus k, that is x of 6. Then x of 1 is just you need to put conjugate. So x of 1 will be x of 5 conjugate. X of 2 will be x of 4 conjugate, correct? X of 3 will be x of 3 conjugate. This will not required here. X of 4 will be x of 2 conjugate, and x of 5 will be x of 1 conjugate. Now what you require, see, x of, these are all capital ones, no, these are small x. Okay, we'll do it. So capital X of 1, capital X of 1 is capital X of 5 conjugate. Capital X of 5 conjugate means 1 plus j. This is correct. Capital X of 1 is capital X of 5 conjugate. Capital X of 5 is 1 minus j. इसका conjugate क्या होगा? 1 plus j. Capital X of 4. Capital X of 4 is x of 2 conjugate. Capital X of 2 is 2 plus j2. Its conjugate is 2 minus j2. Very good. Now I need small x of 0. So students, small x of 0 is nothing but 1 upon n summation for all the samples from k equal to 0 to n minus 1 capital X of k. 1 upon n is 1 by 6 sum of all the samples of x of k. सभी को ऐड करना है. But conjugate, when you say conjugates na, the imaginary parts will cancel each other. Just you need to add the real parts. That's it. 9, 3. Okay, 9 plus 3. Okay, I need to write. Okay, 9 plus 2 plus 3 plus 1. And which one is missing here? 0, 2, 3. Fourth one is missing. This is the fourth one. Which one is missing? Fifth is 0. 1 is missing now. So x of 1's real part 1. So add 9 plus 2 11 plus 3 14 plus 1 15 plus 1 16 plus 2 18. 18 18 Hanji, divided by 6. So answer will be 3. Option D. And I believe whatever MSQs I have taken in this session, these are the brilliant questions from my side, and I request all of you to share this link in all your contacts. How many of you want the PDF of this session? कितने बच्चों को PDF चाहिए? Who all wants PDF? Do join my Telegram group now. And yeah, just join the Telegram group. How many of you liked the session? कितने बच्चों को सेशन एकदम बढ़िया लगा, मजा आ गया बिल्कुल सेशन में? Quality questions with quality concepts, varieties. How many of you? Can you all comment? Ashok is responding. Tuhin Das. So thank you. Thanks Raghuram. Thanks everyone for joining this session. Don't forget to hit the like button. If you have not hit the like button, it's a request from my side. Hit the like button. Join the Telegram group, and don't forget to join tomorrow's partial differential equations session. Students, yes, Vishal Badri, thank you. Students, I request you to join my tomorrow's partial differential equation. Partial differential equation. Timing is 6 p.m. Same channel. Can you see the link? I will provide the PDF on my Telegram group within 10 minutes from now. How many of you are going to download this? Students, don't forget to join my partial differential equations session tomorrow at 6 p.m. YouTube, same channel. I request all of you to hit the like button for that session also. Put the notifications on so that you will be getting notified before the session. You'll get the reminder. Thanks a lot for coming to this session, students. Love you all. Take care. Stay happy. Stay safe. Jai Hind. Jai Bharat.